Good day, fellow scientists. Another day, another reason to learn physics. In this video, we're going to talk about units and measurements, 1D, 2D, and of course, the Newton's law. So, let's buckle up and let's get to it. Measurements. So, measurements in physics refers to the process of quantifying physical properties or phenomena by assigning numerical values and units to those properties. These measurements are crucial for understanding and describing the behavior of the physical world. They provide a way to express attributes such as length, mass, time, temperature, energy, and various other physical quantities in a standardized and quantifiable manner, often using well-defined units of measurements. Measurements in physics are the foundation of the experimental science, enabling scientists to collect data, make predictions, test hypotheses, and uncover the fundamental laws governing the physical universe. So the table shows different types of basic quantity, its SI units, and its symbols. Unit conversion. Unit conversion is the process of changing a quantity expressed in one set of units into an equivalent quantity in another set of units. It is often used to express the same physical quantity in different forms that are more convenient, relevant, or understandable in a given context. In converting units, a problem here is a weightlifter can lift 495 pounds. How many kilograms is that? So, first thing we need to do first is write the conversion factor. So, 1 kilogram is equals to 2.2 pounds. In doing the dimensional analysis, we need to write down first the given data that is needed to be converted. So, we write down the 485 pounds. A fraction must be added into the equation. So, 1 kilogram in the numerator and 2.2 kilogram in the denominator so that the units would cancel out. So in this equation, 495 pounds multiplied by 1 kilogram over 2.2 pounds is equals to 225 kilogram, meaning a weightlifter can lift 495 pounds, meaning he can also lift 225 kilograms. Second example is convert the speed of 72 kilometers per hour to meters per second. So, to convert from kilometers per hour to meters per second, you can use the following conversion factors. The first conversion factors is 1 kilometer is equal to 1000 meters. And the second conversion factor is 1 hour is equivalent to 3600 seconds. Step 1. Convert kilometers to meters first. So, 72 kilometers is the given. So, 72 multiplied by 1000. 1000 is meters within a kilometer. So, 72 multiplied by 1000 is equals to 72,000. So, it is 72,000 meters. Step 2 is convert hours to seconds. So, according to the conversion factors, 1 hour is equivalent to 3,600 seconds. So, 72,000 meters per 1 hour is equivalent to 72,000 meters per 3,600 seconds. So, 72,000 over 3,600 is equals to 20 meters per second. Therefore, 72 kilometers per hour is equivalent to 20 meters per second. So next topic is 1D motion. One-dimensional motion refers to the motion of an object along a straight line, typically represented on a one-dimensional coordinate axis. This type of motion is characterized by its position, velocity, and acceleration in a single direction. Example number 1. A car is initially at rest. It accelerates at a constant rate of 2 meters per second squared for 5 seconds. What is the final velocity of the car? You can use the following kinematic equation to find the final velocity of the car. Bf is equals to Bi plus At, where Vf is the final velocity. It is what we want to find. Vi is the initial velocity, which is 0 meters per second since the car is initially at rest. A is the acceleration, which is 2 meters per second squared. And lastly, t is the time, which is 5 seconds. Now plug in the values. Vf is equals to 0 meters per second plus 2 meters per second squared multiplied by 5 seconds. So it is equals to 10 meters per second. So the final velocity of the car is 10 meters per second. The object is dropped from a height of 80 meters. Calculate the time it takes for the object to hit the ground. You can use the following kinematic equation to find the time it takes for the object to hit the ground when dropped from the rest. H is equals to 1/2 gravity times t squared, where h is the height, which is 80 meters, g is the acceleration due to gravity. It is approximately 9.81 meters per second squared. T is the time. It is what we want to find. So we're going to rearrange the equation to solve for t. T squared is equals to 2h over g. Now plug in the values. T squared is equals to 2 multiplied by 80 meters over 9.81 meters per second squared. So t squared is now 16.30 seconds squared. To find t, take the square root of both sides. So t is now equals to 4.04 seconds. So it takes approximately 4 seconds for the object to hit the ground when dropped from a height of 80 meters. Moving on to two-dimensional motion. Two-dimensional motion refers to the study of motion and physical phenomena in a plane, typically defined by two perpendicular axes. In this context, it is often necessary to consider both the horizontal and vertical components of motion. In this given problem, a projectile is launched with an initial velocity of 20 meters per second at an angle of 30 degrees above the horizontal. Calculate the following. The time it takes for the projectile to reach its maximum height, the maximum height it reaches above its starting point. To find the time it takes to reach the maximum height, we can use the following kinematic equation. By is equals to Bo sine theta minus gravity multiplied by time. Vy is the vertical component of velocity, which is 0 meters per second at the maximum height. Vo is the initial velocity, which is 20 meters per second. Theta is the launch angle, which is 30 degrees. G is the acceleration due to the gravity, approximately 9.81 meters per second squared. And lastly, t is the time we want to find. So rearrange the equation to solve for the t. So 0 is equals to 20 meters per second sine 30 minus 9.81 meters per second squared multiplied by t. So when we rearrange it, it will become t is equals to 20 meters per second sine 30 over 9.81 meters per second squared. So plug in, we will have t is equals to 1.02 seconds. To find the maximum height, we can use the following kinematic equation. Height is equals to Voy time minus 1/2 gt squared, where h is height. It is what we want to find. Boy is the initial vertical velocity. It is calculated from Bo, and data. T is the time, it is 1.02 seconds. So first we need to calculate the VOY. VOY is equals to 20 meters per second sine 30 data. It is equals to 10 meters per second. Now plug in the values to find h. Height is equals to 10 meters per second multiplied by 1.02 seconds minus 1/2 multiplied by 9.81 meters per second multiply by 1.02 seconds squared. So the height is equals to 5.10 meters. Down to our last topic, let's discuss the Newton's law. Newton's law of motions are three fundamental principles that describe the relationship between the motion of an object and the forces acting upon it. They were formulated by Sir Isaac Newton in the late 17th century. Here are the three laws. The first law is the law of inertia. An object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an unbalanced external force. A problem here is a car is traveling along a straight road at a constant speed of 60 miles per hour. Suddenly, the driver takes their foot off the accelerator and let the car coast. Explain the car's motion according to Newton's first law. So, in this case, the car was initially moving at a constant speed of 60 miles per hour. When the driver takes their foot off the accelerator, no additional force is applied to change the car's state of motion. Therefore, the car will continue to coast along the road at 60 miles per hour in a straight line. This is an example of law of inertia in action, as the car maintains its state of motion until external force, such as braking or steering, is applied. The second law is the law of acceleration. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This law is often written as F is equals to ma, where F is the force, m is the mass, and a is the acceleration. So a problem here is a car with a mass of 1000 kilograms is subjected to a net force of 500 newtons in the forward direction. What is the car's acceleration? To find the acceleration, you can use the Newton's second law, which is Fma. In this case, the force is 5000 newtons and the mass is 1000 kilograms. Plug these values into the equation. So, force is equals to mass acceleration. So, 5000 newtons is equals to 1000 kilogram. The A is missing. So, our A is now 5000 newtons over 1000 kilograms. It is equals to 5 meters per second. So the car's acceleration is 5 meters per second squared into the forward direction. And the third law is the action-reaction law. For every action, there is an equal and opposite reaction. In other words, if object A exerts a force on object B exerts an equal and opposite force on object A.